Hello my dear viewers. I was yet again bullied by my crippling imposter syndrome into making a new video. So let's talk about voxel occupied bit optimization. That's right, Shokovox has occupied bits, just like your mom. Every time I try to grind on my code, I hear this sound, so that ain't good. I figured I could just do a video to unjumble my brain so it won't feel like a raisin anymore. I will try to separate my giant project into multiple shorter videos where each video will only have the minimum necessary amount of yap yap, so I'm not scaring y'all with words like I'm a witch in a Shakespearean play. You dumb fuck. I am assuming that the average human attention span is the rough equivalent of a ripe potato, and I am keeping true to that, as in I do not want to explain in great depth or detail everything and anything. I will have deep dive videos exactly for that. For now, I will instead dump down everything so you can mistake this as entertainment when you squint really hard.
Do we even know who is this
Raytracing?
What is a ray? In short, it is an arrow. It points to stuff. A ray has an origin and a direction. It expands infinitely in that said direction. That's what big mathematics want you to think, so they can sell you more linear algebra. Bastards! Most brains usually have one or two eyes attached to it, which accepts light and converts it to images. These images are caused by receptors in your eyes activated by light, more specifically light rays. Some people thought they could ruin this with math, so they said let's pretend that the lights are rays, and bam, ray tracing was born. Now simulating this is very costly because most of the rays don't even reach your eyes. Smart people figured out an effective way to simulate this by reversing the rays so they originate from the eye instead. Objects hitting the ray are visible. In our case, objects are teeny tiny little QB bodies. In order to display them on the screen without any shadows, reflection, transparency, and with barely any extras, we need to tell which cubes are hitting the rays, and we need to do it as effective as possible. It needs to be effective because if anyone is to build a game on top of this, they are sure as hell not going to like it when we hog the GPU all for ourselves only for the sake of rendering. One technique for effective rendering is storing if a voxel is occupied and skipping empty spaces while iterating the ray. Skipped areas mean faster iteration, which ultimately means you can have more juice for later features. The smallest possible space you can store this information is inside one bit in binary, where 0 means empty and 1 means occupied. Group 8 of these together and you get a byte, which is the smallest data computers can store. This is called occupancy bit masks or occupied bit masks. Inside the byte, individual bits can still be accessed separately. So storing information like this is the most compact you can go. These bytes are stored next to the actual voxel data inside the GPU and updated whenever the octree is updated. For Shokovox, it's a bit more generic, as I define this for areas. An area is divided into 4 on all dimensions, which results in a field of 4x4x4 or 64 cells for one area. I'll just show you a 2D version of this, which is a grid, but imagine the 3D counterpart is like a lasagna, but there's grids on the layers. Mwah! For each cell, the corresponding bit is set to 1 if there's anything contained in it, and it is set to 0 if nothing is inside. You don't need to restrict this to voxels though. In Shokovox, occupancy information is stored for more generic areas instead, where an area has multiple voxels in it. This area can be of any size except it has to be aligned to the octree structure, which means the size of each cell has to align to the multiples of 2. And because the octree is a recursive data structure, this is repeated on every level. Oh, well, I see somebody raised hands. Yes, is there a question? What is recursion? Structurally speaking, recursion is very similar to fractals. Okay, yes? What are fractals? Right. In layman's terms, fractals are structures repeating within themselves on a smaller scale. It makes sense when you look at, for example, a Mandelbrot fractal visualization. There you can see that the structure is repeating itself when you zoom in infinitely. You can even visualize this in 3D. Link in the description. For us, this essentially means that within a defined area lies 8 smaller grids with the same structure where the same rules apply. I often address these as children, referring to nodes in a graph. Every node is aligned to start at a multiple of 2. Let's take a look. Observe a majestic lonely tree. Unfortunately, due to complexity concerns, I can only display one level of bit masks meaningfully at the time, but this shouldn't be a problem because this way you can see the different bit masks put together on the same level. This way you can better see that the higher level bit masks are larger than the lower level masks, which is essentially because they cover more area for the same stored data. The cubes colored in blue signify that in that particular cell there is content, so arrays won't skip this area when encountering it. The iteration algorithm actually checks for the opposite of that, meaning an area only gets evaluated if it has anything in it, or to be more precise, anything interesting to the array. With this, I can store the occupancy information for about half a gig worth of data on only 6 kilobytes, which is just a rough estimation. Should this be a conversation, at this point I usually get some questions for some much needed clarifications, so if you have any questions in you, please don't hold back, write it in the comments. I hope you found this video useful and I've managed to convey the basics of what this is. And I am really glad to keep you entertained while I struggle with basically most aspects of making a YouTube video. I don't think this is a complete solution by any metric, but since this is open source, everyone has a chance to improve upon it, and I believe I am making this easier with videos like this. As for upcoming videos, GPU streaming is on the radar, but I really want to go into deep dives in the future as well. And while my target are game developers, I think this could do well for artists, so I have some plans to implement some features for them as well. So, what did you think? Was this useful to you? If there was a mistake anywhere, let me know, write a comment, I'd love to mitigate it. This is partly why I'm here. Also, help me find what you are interested in, leave a comment, leave a wish, do a critique, whatever you want. Like the video, recommend it, share it, put it in a stew, leave, laugh, subscribe. Auf Wiedersehen!